Welcome back, everyone. This is Unit 6, Lesson 3, Negative Exponents. The iXL code associated with this lesson is on the screen right now, SCM. So at the end, please go ahead, enter that code into iXL, and complete your assignment for today. For this lesson, you'll need some paper and a pen or a pencil, some sort of writing utensil. I will be asking you to complete a few practice problems, and similar to the last lesson, I'm going to ask you to not use a calculator during this lesson. I need you to prove to me and to yourself that you truly understand how to work this out. And the only way to do that is if you're able to do that on your own without the help of a calculator. This video is going to be broken up into two parts. The first part is going to be focusing on the basics, this idea of rewriting negative exponents. In part two, we're going to take what we learned and we're going to apply it with this idea of evaluating negative exponents, similar to what we've done in the previous lessons. Of course, we're going to be starting with the basics. We're going to start talking about rewriting negative exponents and truly understanding what they mean. As we go through the lesson, I would recommend that you have your paper out, write down some of the examples that we're going to be working on. That way, when you get to your assignment, you're able to use that as notes. For our first two examples, we're being asked to rewrite the expression with positive exponents. Our first example says 7 to the power of negative 4. But again, the question is asking us to change that negative exponent to a positive exponent. In order to do that, we first need to understand negative exponents a little bit more. Whenever you see a negative exponent, you need to think about fractions. Negative exponents always deal with some sort of fraction. As you might remember, if we want to make a number, or in this case, a number and an exponent, 7 to the power negative 4, if you want to make that into a fraction, all we have to do is put that over 1. 7 to the power negative 4 is in the numerator on top, and 1 is in the denominator at the bottom. To change the sign of an exponent, we need to move that exponent and the base that it's attached to the opposite side of the fraction. In this case, 7 to the power of negative 4 is going to move to the bottom of the fraction, to the denominator. Let's go ahead and write our fraction. Here's my fraction bar. So I'm going to move the 7 and the exponent to the power 4 to the denominator. But when I do that, the exponent was negative, but now it's a positive exponent. This 1 that was already in the denominator is technically still there. But it doesn't say 17 to the power of 4. This is actually multiplication. So the one that was already there is being multiplied with what we brought down to the denominator. So it's 1 times 7 to the power of 4. On top, in the numerator, it looks like there's nothing there anymore, but there's actually going to be an invisible 1. We'll talk about why that's true a little later in another episode, but for right now, because there's nothing on top, there's nothing in the numerator, we're just going to put a 1 right there. To simplify this a little bit more, we need to look at the denominator and that multiplication that's going on down there. Whenever we multiply some number by 1, our answer shouldn't change. So even though we still have that 1 right there, technically we don't need to write it down because 1 times anything is that other number. So that means that our final answer for this first problem is going to be 1 over, and in the denominator, we just have 7 to the power 4. That's it. This is your final answer for the first example. We're going to be doing the same thing for the second example, 1 divided by 8 to the power of negative 5. As we said before, because we want that negative exponent to become a positive, all we have to do is move it to the opposite side of our fraction. So instead of being in the denominator, it's going to move to the numerator. So for this problem, that means that in the numerator, on top of our fraction, we do have 8 to the power of a positive 5. It's not going to be negative anymore, it's going to be positive. But we still have this 1 that was already there from before. So let's go ahead and include that as part of our problem. And again, this does not say 18 to the power of 5. This is 1 times 8 to the power of 5. In the denominator, we have an invisible 1. And if we want to simplify this, which we do in this case, 1 times 8 to the power of 5 is 8 to the power of 5, and our denominator is just 1. Even though this is correct, there's still one more step that we can take. Because we have 1 in the denominator, we technically don't need to write it down. This is the same thing as saying just 8 to the power of 5. And this would be your final answer for this problem. Again, both of these are technically correct. They both have positive exponents. The one on the right, this 8 to the power of 5, is a little more correct. It's a little simpler. Let's move on to something a little more complicated. Here we have what looks like to be the same problem, or at least something very similar, but the obvious difference is that one example has parentheses and the second one does not. But still, we're being asked to do the same thing. We're being asked to rewrite this expression with positive exponents. So let's go ahead and do that. As we talked about in the previous example, because we have a negative exponent, we have negative 12 to the power of negative 3. The negative 3 is a negative exponent. We want to think about this problem as a fraction. We need to think about it as a fraction. To make this example into a fraction, all we have to do is put it over 1. So we have parentheses negative 12 to the power of negative 3, and in the denominator we have a 1. Again, we're trying to make that negative 3, that negative exponent, into a positive, so we have to move the exponent and the base that it's attached to the denominator. Because of the parentheses, everything inside the parentheses is attached to that exponent, to that negative 3. So all of that is going to be moving down. That means that our answer should look something like this. In the denominator, we brought down the negative 12, and the exponent is still a 3, but instead of a negative, it became a positive because we moved it to the other side of the fraction. We still have this 1 that was already in our denominator, and that actually has to stay. We still have a 1 right here. And again, these two are being multiplied. In the numerator, because we moved everything down, it looks like we don't have anything, but like we talked about before, there should be an invisible 1 right here. I know that some of you at this point are thinking, Mister, that 1 at the bottom, that times 1, why are we even writing it? Can't you just ignore it? And for these examples, you're right. You can technically just ignore it. However, again, these are the basics. When it gets a little bit more complicated, I need you to understand that there is multiplication happening. That's going to help you better understand a little more complicated problems that we're going to do later on. To finish up this answer, we're just going to go ahead and multiply that 1. Again, it doesn't change anything in the denominator except that we're not going to write down that 1. So in the denominator, we have parentheses negative 12 close parentheses to the power of 3. Remember, the exponent is on the outside of the parentheses for this example. And in our numerator, we have a 1. And we're done. We wrote the expression without any negative exponents. Let's do the next example now. We're going to start off by making this into a fraction. So we have negative 12 to the power of negative 3 over 1. And again, we're trying to make that negative exponent into a positive exponent. So we want to move this down. But the main difference between this example and the one that we just did is that this one doesn't have any parentheses, which means that our exponent is only attached to the 12. The negative is not going to be brought down. It's going to stay in the numerator. The only thing that's going to be moving to the denominator is the 12 and the exponent. So when we move this around, we have in our denominator 12 to the power of 3. Again, the exponent was negative. It became a positive 3. We still have this 1 that was already in the denominator. And again, this is being multiplied. And in our numerator, we have a negative that we didn't move. It stayed in the numerator, so it still has to be there. But a negative what? Well, same as before, there's an invisible 1 up here. So it's a negative 1 in the numerator. And when we simplify this out, this is going to equal negative 1 over 12 to the power of 3. We just rewrote our answer with positive exponents. That negative 3 is now a positive 3. Now it's your turn. Here are 3 examples similar to the ones that we just did. Prove to yourself that you were paying attention, that you understood what was going on. If you need some help, please go back a few seconds, try to understand the previous examples. If you feel like you need more time, if 1 minute is not enough, please pause the video and then continue when you are ready to go. Your time starts now. That was it. That was a minute. Let's go ahead and review these answers and see how you all did. And here are your answers. For the first problem, 4 to the power of negative 7. Again, that exponent is attached to the 4, so the whole thing goes down. The negative exponent becomes positive. That one should have been pretty easy. For the next example, your answer should be negative 1 over 5 to the power of 3. Remember that the negative exponent is only attached to the 5, so the negative is actually not going to be moving down to the bottom of the fraction, only the 5 and the exponent is going to move down. So on top, that's why you still see a negative 1. And for the last example, similar situation, because the exponent, that negative 5, is attached to the 3 and not the negative, because there's no parentheses, that part in yellow, that 3 to the power of negative 5, that's what's going to move up to the other side of the fraction, the numerator. That's how we get that fraction, that's how we get the exponent to become positive. For the last example, yes, the answer is 3 to the power of 5 over negative 1, but that could actually be simplified. Our answer is going to be a negative 3 to the power of 5. Before we move on to harder examples, there's one more thing that I want to make sure that we understand. For this problem, we're being asked to rewrite the expression with negative exponents. So in this case, we're going to be doing the opposite. Instead of going from a negative exponent to a positive exponent, we're going from a positive to a negative. It's basically the same process. Because we are dealing with negative exponents, we want to make sure that we are still working with a fraction. For the first example, 7 to the power of 4 is going to become 7 to the power of 4 over 1. Because we want to change the exponent from a positive 4 to a negative 4, that means that everything on top, in this case 7 to the power of 4, because the 4 is attached to the 7, it's going to be moving down to the bottom. That means that our answer is going to be 1 over 7 to the power of negative 4. Remember that when you move the exponent and the base to the opposite side of the fraction, the exponent is going to change signs. So it was positive when it was in the numerator. When you switch it down to the bottom, it becomes a negative. So that is our answer for this first example. For this second example, we have 1 over 30 to the power of 23. Yes, the numbers are a little big, but I want to make sure that you understand that even though we have big numbers, the thinking is still the same thing. That shouldn't scare you. Again, we want this 23, that exponent, to become a negative exponent because that's what the question is asking us to do. So in order to do that, we need to move it to the other side of the fraction. So we're going to be moving this to the top, which means that our final answer is going to be 30 to the power of negative 23 over 1. Or we don't have to put that 1 at the bottom. This is the same thing as saying 30 to the power of negative 23. Here are 2 problems that I want you to try by yourself. Again, you're being asked to rewrite the expression with negative exponents. Give this a shot. You have 30 seconds. Again, if you feel like you need more time, stop the video, press play when you're ready to go. 30 seconds, go. That was 30 seconds. Let's see how you did. Again, we're being asked to write our answer with negative exponents. For the first problem, we have negative 9 to the power of 10. That exponent, that 10, is positive and we want it to be negative. Like we said before, because we're dealing with negative exponents, we want to make this first number into a fraction. And because we want to change the sign of the exponent, we're going to move everything to the other side of the fraction. And I shouldn't say everything because technically the 10, the exponent, is only attached to the 9. The negative is not going to move down. That means that your final answer should be a fraction where you have a negative 1 on top because of the negative that stayed, and in the denominator you should have 9 to the power of negative 10. Again, the exponent was positive in the numerator, but because we moved it to the other side of the fraction, it became a negative number. So this is your final answer for the first example. For the second example, we have 1 divided by parentheses negative 8 to the power of 5. Again, we want that 5 to be a negative exponent, so we need to move that 5, that exponent, and the base, which in this case, because of the parentheses, it's negative 8. All of that is going to move to the top, to the numerator. That means that our final answer should be a fraction with parentheses negative 8 to the power of negative 5 in the numerator and a 1 in the denominator. Because we have a 1 in the denominator, we could technically ignore it because anything divided by 1 is itself. Our final answer here is going to be parentheses negative 8 to the power of negative 5, and that's it. Now that we reviewed the basics, let's go ahead and practice how to evaluate negative exponents. This is a little harder, but if you've done the last few lessons, then this shouldn't be too bad. This problem is asking us to write our answer as a fraction or a whole number without exponents. So even though our problem has an exponent, our final answer should not. Again, our final answer should just be a fraction or a whole number. When we've done evaluating in the past, in the last few lessons, we've done that with positive exponents. So that means that even though we have a negative exponent, in order to evaluate this, we needed to have a positive exponent. Let's do the same thing that we did in the previous problems. I see a negative exponent here, so I'm going to make this into a fraction. Because of that negative exponent, I know that I'm going to have to deal with some sort of fraction. Our exponent is attached to a base of 2, so we're going to be moving all of that to the bottom, to the other side of the fraction. Once we move things around, we're going to have a 2 to the power of 4 in the denominator and a 1 in the numerator. So that's our first step. We have a positive exponent. Now this looks like something similar to what we did in the previous lessons. Because we're being asked to evaluate, we need to understand what an exponent is doing. For this problem, well, the 1 in the numerator is not going to do anything. It's just a 1. But in the denominator, because we have 2 to the power of 4, we know that that means 2 times 2 times 2 times 2. At this point, you could figure out your answer whichever way you think is fastest, as long as you are not using a calculator. Remember, we're trying to make sure that we understand how to do this by hand or in our heads. Here we have 2 times 2, which is 4, 2 times 2, which is also 4, and then 4 times 4, which is 16. Which means that our final answer is going to be 1 over 16. It's a regular fraction. It has no exponents. This is our final answer. Let's do one more example like this just to make sure that this makes sense to us. Again, because I'm trying to evaluate, we actually don't want a negative exponent. So we need to change that negative exponent at the bottom, that -2, into a positive exponent. Like we've done before, we're going to move all this and in the denominator to the numerator, which is going to give us 3 to the power of 2 over 1, which is just the same thing as saying 3 to the power of 2. We don't need the 1 in the denominator. It's still there. It's an invisible 1 in the denominator, but we don't need to write it right now. Our answer right now still has an exponent, and we don't want that, so let's go ahead and do the next step. What is 3 to the power of 2? Well, we know that that's just 3 times 3, which is equal to 9. 9 is our final answer for this problem. Now it's your turn. Prove to me that this makes sense to you. You have 1 minute to answer 3 problems. If you need to pause, please pause and go ahead and press play when you are ready. You have 1 minute. Your time starts now. That was 1 minute. Let's go ahead and review these problems together. For the first problem, we have 4 to the power of -3. Again, when we're evaluating, we could do that if we have a positive exponent. So let's get rid of that negative. Let's make it into a positive. We're going to start off by making this into a fraction. We know that this negative exponent is attached to the 4, so let's move everything to the denominator. Here we have 1 over 4 to the power of 3, which is the same thing as saying 1 over 4 times 4 times 4. Again, that's 4 times 4 times 4 because of the 3, because of our exponent. And again, please make sure that you're doing this by hand. 4 times 4 is 16, and 16 times 4 is 64. So our final answer for this first problem is 1 over 64. For the next one, the -2, that exponent, is only attached to the 3, not the negative. Again, there is no parentheses, it's only attached to the 3. So when we move this up to the numerator, the negative in front of the 3, this one right here, is not going to move. It's going to stay in the denominator. So let's go ahead and move that up. We have 3 to the power of 2 over, the negative stays in the denominator, and we have a 1. Now let's evaluate. We know that 3 to the power of 2 is the same thing as saying 3 times 3. In the denominator we have -1. 3 times 3 is 9 over -1. And 9 divided by -1 is the same thing as saying -9. So for this problem, our answer is just -9. And last but not least, we have 5 to the power of -1. For this one, it's not a fraction, so let's go ahead and make it into a fraction by putting it over 1. The negative exponent is attached to 5, so let's move that to the bottom in order to make the exponent a positive. Here we have 1 over 5 to the power of 1. And like we talked about in the previous lesson, 5 to the power of 1 is just 5. So our answer here is just 1 over 5. We don't need that 1 as the exponent. That's it. So that's technically it. If you feel comfortable with what we reviewed and you feel like you want to go ahead and start practicing on iXL, please skip this next part and just go to the end where I give you the iXL code. If you want to push yourself and try to understand this next part, negative exponents and fractions, and how that's a little different, please go ahead and stay tuned. Let's go ahead and review that together. Here we have in parentheses 1 divided by 5, close parentheses, to the power of -2. There's a few ways that we could try to understand this problem. However, some of the ways that I could try to explain this, we actually haven't learned yet. So I will talk about this type of example again in another video once we learn more about exponents. But for right now, we're going to use the same thinking process that we've been doing with the other examples. Again, we're trying to evaluate this, and we've done similar problems before, but those examples in the other lessons, when we were talking about fractions, those had exponents that were positive. The difference here is that it's a negative exponent. But like we did in the previous examples, when we're evaluating, we want a positive exponent. So here, the thinking is slightly different. We have a negative exponent, which means that we are going to be dealing with fractions. And in this case, we already have fractions. We have the fraction of 1 divided by 5, where 1 is in the numerator and 5 is in the denominator. So for this example, in order to make this exponent into a positive 2, we're going to be moving the numerator and the denominator inside of the parentheses. That's how we're actually going to go ahead and get rid of that negative. So if we look back at our original problem, this 5 is actually going to go to the top. The denominator is going to move to the top, and the numerator, the 1, is going to move to the bottom. So here we're going to have a 5 in the numerator, a 1 in the denominator, and now we have something that's a little easier to work with. We have 5 divided by 1 to the power of 2. From here, there's two ways that you could think about this final part. If you are using the order of operations, we're going to look inside of our grouping first, inside of our parentheses, and we see that we have 5 divided by 1. We know what 5 divided by 1 is. 5 divided by 1 is just 5. Let's go ahead and keep that exponent on the outside. And all we have is 5 times 5 is equal to 25. So 25 is our final answer. Another way that you could have thought about this is by thinking about this exponent first. Yes, technically, according to the order of operations, you will work inside of the grouping, but in this case, the exponent could have also worked. Again, because the exponent is attached to everything inside the parentheses, you could have also written it as 5 over 1 times 5 over 1. Again, everything inside of the parentheses is being multiplied by itself 2 times. All we have to do now is multiply this. 5 times 5 is 25. At the bottom, 1 times 1 is 1. We have 25 over 1, which is the same thing as 25. Thank you so much for making it to the end. Here is your practice code on iXL SCM. Same as before, your goal is to try to get a 70 to show me that you have a basic understanding of this material. If you want to push yourself, prove to me that you truly understand this, that you are a true master of this, aim for 80, 90, or 100. If you have any questions, please send me a message either on Remind, on Schoology, or stop by during office hours on Zoom. Also, if you have any feedback for me, if there's something that you would like me to change about these videos, if there's something that you think I could do better to better teach you, please let me know and I'll do my best to give you what you need. Have a good rest of your day. Please be productive. I'll see y'all later.